Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that, what is mechanical energy? Mechanical energy is the sum of kinetic energy and gravitational potential energy in the system. Yeah, then we come to this question. It says that state the law of conservation of energy. It states that energy cannot be created nor destroyed, but it just changes from one form to the other. Yeah, then we come to this question. It says that state the principle of conservation of mechanical energy. It states that the total mechanical energy of a closed system remains constant, or the total mechanical energy of an isolated system is conserved. Yeah, that's that. Yeah, then this question comes. It says that a stone of mass 80 grams is held at a height of 12.4 meters. Okay. And this question comes and says, calculate the potential energy of the stone. Okay, this is what we have to remember, that potential energy is given by EP equals to mgh. Okay, so let's check what we have. EP is what we are calculating, and the mass is 80 grams. But we need to remember that the SI unit for mass is kilograms. So what do? We convert it to kilogram by dividing with 1,000, giving us 0.08 kilograms. Okay, what else do we know? We know the height. The height is 12.4 meters. So this is the information we have. And next step is to substitute. The mass is 0.08. Then G is a constant, which is 9.8. Then the height is 12.4. Yeah, giving us. Yeah, then this question comes. It says that what is the kinetic energy of the stone when the stone reaches the ground? Okay, so how do we go about this? Here we use the principle of conservation of mechanical energy. It says that total mechanical energy at the top, before the stone is released, is equal to total mechanical energy at the bottom. Okay, but you have to remember that kinetic energy is equal to EK plus EP. So this is going to be EK top, and this is EP top, and which is equal to kinetic energy this side at the bottom plus potential energy at the bottom. Next, we can open this one up. What do we have here? It is half mv squared, but top, the verse at the top, plus mgh at the top, which is equal to half mv squared at the bottom plus mgh at the bottom. Now remember, the stone was initially held. Yeah. So if it was initially held, it means that this velocity is 0. So we are going to have a half times mass, which is 0.08 times 0 squared. Okay, plus, yes, what's this one? It's going to be 0.08 times 9.8 times height, which is 12.4, giving us this side. Yes, this one, because we are calculating the kinetic energy, we can leave it here as EK at the bottom. But when we substitute for this one, it's going to be 0.08 times 9.8, and on the ground the height is 0. So from this information, what do we get? Here we have 0. Okay, plus this figure. This is the potential energy at the top. We got it already. It is 9.72. Okay, which is equal to kinetic energy at the bottom, because this one is also 0. So that is it. So what have we noticed? That the potential energy at the top is equal to the kinetic energy at the bottom, because mechanical energy has been conserved. Yeah, then we come to this question. It says that using the value of the kinetic energy in Roman number 2, calculate the velocity of the stone. Okay, how do we go about this? This is what you have to know. We need the equation. The expression for kinetic energy is this: a half mv squared. So check, what do we have? We are using the kinetic energy we obtained, which was 9.72 joules. Okay, what else do we know? We know the mass. The mass, we said it's 80 grams, which comes to 80 divided by 1000, giving us 0.08 kilograms. And we are looking for velocity. Okay, what do we do? Yeah, we substitute here. We are going to say EK, which is 9.72, is equal to a half times mass, which is 0.08, times velocity squared. Yeah, from this, what do we get? We have 9.72 giving us 0.04 velocity squared. So what do? We have velocity squared giving us 9.72 divided by 0.04. Yeah, we have this. 243 is equal to v squared. But we are looking for v. What do? We find the square root of both sides. This one gives us v equals to, giving us 15.59. meters per second. Yeah, that's what we have for the rest of the stone when it hits the ground. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yeah, we urge you to subscribe, comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye bye.